Hello and welcome back to the channel. In today's video, I'm going to be talking about the Year 6 SATs and specifically the reasoning papers and the 7 different types of reasoning questions that can come up on a SATs paper. So, single step worded problems, multiple step worded problems, problems involving measure, problems involving drawing, explanation questions, sequence questions, and ordering questions. So let's start off with the single step worded problems. So these questions are usually a little bit easier because there's only one step involved. They are questions that involve the children doing some sort of calculation once they've understood the maths that they need to pull out of the question. So let's have a look at an example. I think this is from last year, but it's a previous SATs question. The cheese costs £1.35. Amina pays with a £2 coin. How much change does Amina get? So we know that she has £2. We're going to write that down first. And we know that she pays £1.35 for cheese. So what we actually need to do here is a simple subtraction to work out and calculate how much change that Amina gets. So straight away, I can't take away here because these are too small. So I'm going to borrow from the 2. That becomes 1. That becomes 10, which becomes 9. And that becomes 10. So now I can solve this. 10 take away 5 is 5. 9 take away 3 is 6. And then 1 take away 1 is 0. Leaving with us a final answer of 0.65 or 65 pence. So this is an example of a single step worded problem, the first type of reasoning question that could come up. Here are some similar questions. Again, a cuboid has a side length of 4 centimeters, 3 centimeters, and 4 centimeters. What is the volume of the cube? So there is some maths knowledge the children would need to have here, and that is how to calculate the volume of a cube. And it is length times width times height. So we're going to multiply these 3 numbers together. So we do 4 multiplied by 3, first of all, which gives us 12. And then we do 12 multiplied by 4, which gives us 48. So 48 centimeters cubed would be our final answer. Again, there was only one step involved. Here's another one. A car wheel has a radius of 62 centimeters. What is the diameter? So the diameter, if we take a wheel or a circle, the radius is a quarter way, which is half the diameter. So the diameter is double the radius. So if I do 62 times 2 or 62 doubled, I get 120. Okay, and then I do 2 times 2, which is 4. So the final answer is 124 centimeters. Again, there was only one step involved. It's a single step worded problem. Here's another one. Round 7,594 to the nearest 10. So straight away, I'm looking to round the number to the nearest 10. The number is 9 in the tens column, but whenever I'm rounding, I look at the number 4. And the rule is 1, 2, 3, 4, round down to the floor. 5, 6, 7, 8, 9, we round up to the next 10 on the number line. So this number here is 4. So we're going to be rounding this number down. Okay. So 4 here in the ones means we're going to round the tens down. So 7,590 would be our final answer here. But again, only one step. It's a single step worded problem. So that's the first type of reasoning question that they may have to tackle and understand. Then we move on to multiple step worded problems. So this means that there is going to be more than one step involved. And usually these are worth more than 1 mark, sometimes 2, and on occasion even 3 marks. So here, we're going to have to do 2 things. It could be that we're going to have to add and subtract. We might have to multiply and add. We might have to multiply and divide. But it's going to be some combination of the 4 operations or a conversion of some kind. So let's reason and read this question and see if we can work out what to do. Potatoes are £1.50 per kilogram. Carrots are £1.80 per kilogram. Jack buys 1.5 kilograms of potatoes and 0.5 kilograms of carrots. How much change does he get from £5? So straight away, you can see they've given a lot of information here, and the question comes at the end. I would say the first step here is to work out how much Jack has spent altogether before we can take it away from £5. So he buys 0.5 kilogram of carrots. Now, it's 180 per kilogram, but he only buys half. So we're going to have to half the amount that it costs for a full kilogram. So it's going to be 180 divided by 2. Well, we know that 18 divided by 2 is 9. So 180 divided by 2 is 90 or 90 pence. Okay, so the carrots cost us 90 pence. What about the potatoes? So he buys 1.5 kilograms of these. So 1 times a kilogram is £1.50. And then half of 150, because he buys half, a half of 150 is going to be 75. Now, if we add those together, 0 and 5 is 5. 5 and 7 makes 12, 2 down, carry 1. 1 and 1 makes 2. So the potatoes cost us £2.25, but then we have to put that together with the 90 of the carrots. 0 and 5 is 5. 2 and 9 make 11, carry 1. 1 and 2 make 3. So the total cost of these vegetables is £3.15. But we know we may have got a mark at this point, but we're not going to get the second mark unless we work out the change. So that's what the last step is we're going to have to take £3.15 away from £5. So we're going to do £5, take away £3.15, okay, and we're going to have to borrow again. So 4, that becomes 9, that becomes 10. 10 take away 5 is 5, 9 take away 1 is 8, decimal point, 4 take away 3 is 1. So according to our calculations that we've done multiple steps, it's going to be £1.85 change, sorry, that's what they're going to get, change. That's how much change Jack is going to get from what he's spent here. And that would give us 2 marks. So that's how you can see it takes a little bit more time. There's more steps involved. Here's another one, another SATs question, multiple step. Here are 2 boxes. The mass of the first box is 1¼ kilograms. The mass of the second box is 1.4 kilograms. What is the difference in mass of the 2 boxes? Give your answer in kilograms. Well, we're going to have to do some conversion here, aren't we? Because 1.4 kilograms is the same as 1,400 grams. Now we know that a quarter, or we should know, a quarter of a kilogram is 250. So that means that we've got 1,250 grams for this box here. Okay, now we just need to work out the difference. We've done the first step, we've done some conversion. Now we need to work out the difference. So the easiest way to work out the difference is to subtract one number from the other, the smaller one from the bigger one, which is what I'm going to do here. 0 take away 0 is 0. 0 take away 5 we can't do. That becomes 3. That becomes 10. 10 take away 5 is 5. 3 take away 2 is 1. And 1 take away 1 is 0. Meaning that the difference between these two in kilograms is going to be 0.150. Okay. If I was to write it in grams, it would be 150 grams, but they want the answer in kilograms. So there you can see another multiple step worded problem. And again, it's worth 2 marks. Here's another one. I'm not going to work this one out, but I'll read it to you. You can have a go at home. A box contains 2.6 kilograms of washing powder. Jack uses 65 grams of powder of each wash. He uses all the powder. How many washes did Jack do? So that is, we know that 2.6 kilograms is 2,600 grams, and he uses 65 grams a wash. Now, how many washes did he do? This is actually going to involve some long division. So it's actually 2,600 divided by 65. And you'd have to make jottings and work it out. And usually with long division, it's a whole number, which is the answer. I'll let you try and work that one out at home. But you can see again, what's required of the children is a multiple step approach to these worded problems. Okay, let's have a look at another type of reasoning problem now. These are reasoning problems involving measure. Now you might be thinking, well, those other problems involve measure, and that is true. A lot of the problems in the reasoning paper won't just be straightforward addition and subtraction. It will involve multiple parts of the curriculum: addition, subtraction, measurement, units of measurement. Okay, so these problems specifically are to do with measure, and that could be, grams, kilograms, it could be centimeters, meters, liters, milliliters, it could be money. And that's what we've got here. We've got a money problem. A 4 kilogram bag of rice costs £6. What is the cost of 500 grams of rice? Okay, so 4 kilograms of rice costs £6. That's what we know. We know also that 500 grams is half a kilogram. So what am I going to have to do here? I'm going to have to divide 600 by 4 to work out the cost of 1 kilogram. So 600 divided by 4, 4 into 6 goes once with a remainder of 2, 4 into 20 goes 5 times, 4 into 0 goes 0 times. So 1 kilogram, therefore, would equal £1.50. Okay, that's the cost for 1 kilogram. And we know that 500 grams is half a kilogram, so I've got to do half £1.50 or half 150, which I know is 75 pence. Okay, so that's the cost of 500 grams. Again, there are 2 steps involved here. It's not so straightforward, but this is another problem type of reasoning problem involving measure. And the fourth type of problem would involve drawing of some kind. Now, this is a particularly difficult question. It gives you an idea of the kind of things children could be asked on a really tricky reasoning paper. Now, let's see if we can work out what it's asking. Adam has this rectangular piece of card. It is marked with grid lines. Adam makes 2 straight cuts along the grid lines, okay? The 2 cuts divide the rectangle into 3 shapes, 2 squares of a different size, and 1 rectangle. Using the grid lines, draw 2 lines that show where Adam could have made his cuts. Now, there's so much information here. There's also, you need a spatial awareness of space and how we can divide this up. For this question, you also need an understanding of square numbers, because we're asked to make 2 squares. Well, we know squares have to have lengths of the same size. And it's a little bit of trial and error to solve this. We know we need 1 rectangle. So straight away, we're thinking about how we can divide this up. But we have to divide it up so there's no space left. So you could have a square which is 3 by 3, which would make 9. You could have a square which is 4 by 4, which would make 16. But here, it's 5 squares down. So it makes sense if 1 square was 5 times 5, 25. And to do so, I'd need to draw 1 line down here. So Adam could make his first cut down there and make a square, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 in that space. But we need now another square and a rectangle. Well, the obvious place would be to do another cut there, making a square here, 2 times 2, and a rectangle here. Now, I've done this quite quickly, but it does take some thinking, possibly some trial and error of drawing lines and rubbing out. But a tricky question, and all that for only 1 mark. So you can see how children find this reasoning paper difficult. Another problem involving drawing is translating shapes on a coordinate grid. The triangle is translated 7 right and 5 up. Now, with translation, you should always pick a spot on the shape. Now, I'm going to pick this bottom corner and move that spot first before you move any of the others. Okay, so first of all, I'm going 7 right and 5 up. So I'm going to go right first. 1, 2, 3, 4, 5, 6, 7, which puts me here. But I'm not done because I've got to go for 5 up. 1, 2, 3, 4, 5, which puts me here. That means that bottom corner of my triangle is going to go there. Okay. Now I just need to plot the others. 1, 2, 3, and then 3 up, 1, 2, 3. And then with a ruler, obviously, I would draw my lines to show my translated shape. So that's a drawing reasoning problem. Here's another one, which involves measuring angles. Draw an angle at exactly 35 degrees. Now, it's giving us a space to do it. And I've just put here a protractor, because they will get a protractor in the test. And it's for this kind of a question that they would need to use it. Now, putting your protractor here in the middle, and then finding your angle, counting around 10, 20, 30, and then there is 35. So I would draw this angle here. Again, with a ruler would be probably best. And then I could identify it like that. Take my protractor off the page. So that would be my 35-degree angle. Okay, 5th type of reasoning question, explanation questions. This is really reasoning that involves them talking out how they have solved the question or explaining why somebody is correct or not correct. And they should be doing this regularly in their maths lessons to practice. Amina says 600 milliliters is longer than a meter. Explain how you know Amina is not correct. Well, first of all, we know that in 1 meter, there is 100 centimeters. And in 100 centimeters, well, in 1 centimeter, we know there are 10 millimeters. Okay, because 1 meter would equal 1,000 millimeters. And then you might say something like, which is more, than 600 millimeters. So you can see how it takes a little while to work it out, but you can get this right by working out. You can get this right by writing down your thinking in words, but you need to give enough so that you can show your understanding of this question and why it's not right. Here's another one. These pie charts show biscuits in 2 tins. Tin B has 20 biscuits. Tin A has 36 biscuits. Tin B has more chocolate biscuits than tin A. Explain why this is incorrect. Okay, so tin B has 20 biscuits and half of 20 equals 10. So in this one, we've got 10 chocolate biscuits. Here, we've got 36. And if we divide that by 3, we get 12. So that's 12 and that's 10. Explain, well, we would do something like 36 divided by 3 equals 12. But 20 divided by 2 equals 10. So there are more, therefore, there are more in tin A. Okay, apologies for the handwriting, but you can see how they would have to reason this out, showing they're working. Okay, right, on to the next one, reasoning type 6, sequence questions. So this is where children have to put numbers into a sequence or fill in the gaps in a sequence. So this one says Olivia counts in 8, starting at 0. Take all the numbers she should say. So it's fairly straightforward if the children know their times tables. So we know that 8s are 8, 16, 24, 32, 4 8s, 5 8s are 40, 6 8s are 48, 7 8s are 56, 8 8s are 64, 9 8s are 72, 10 8s are 80, then we've got 88, and then we've got 12 8s and 96. So if I know my 8 times table, it should be fairly straightforward. I can see the number 24 appears bigger than 8 times 12. So I'm going to have to do 8 times, just to check, 8 times 13, 3 8s are 24, 4 down, carry the 1. 1 8 is 8 plus 1. 4 down, carry the 2, sorry. 1 8 is 8 plus 2, 9, 10, 104. What about 8 times 14? 4 8s are 32, 2 down, carry the 3. 1 8 is 8, 9, 10, 11. Okay, so actually, when we look at it, 112 is also in that sequence. So sometimes you need to go a little bit above 12 times 8 to solve these kinds of questions. Here's another one. The numbers in the sequence increase by the same amount each time. Write the missing numbers. Well, straight away, I should start seeing 42, 49, 63. This is my 7 times table. This is 7 times 6, 7 times 7. 7 times 5 is 35. 7 times 8 is 56. 7 9s is 63. And 7 times 10 is 70. So a knowledge and understanding my 7 times table will help me solve that. Finally, number 7 is an ordering question. Similar to sequencing questions, but slightly more tricky. You might be ordering decimals, you could be ordering fractions, you could be ordering mixed number fractions. In this case, this SATS question is saying, write these fractions in order starting with the smallest, which would be straightforward if we had the denominators were the same, which we don't, because that is quarters. And also they've thrown in an improper fraction and they put 6/5. So I need to convert these all into fifths. So they're in fifths already, so I need to convert 3/4 into fifths. So how do I get from 4? I need a common denominator here. So I need to have the common denominator here will be 4 times what goes into 4 and 5. 4 times 5 is 20. Okay, so I got there by multiplying by 5. So that's 3 times 5, which is 15. So 15 over 20, which is the same as 3/4. That's fine. 3/5 into 20ths. That's going to be times by 4. So 4 3s are 12. That's 12 20ths. So this one is 15 20ths, 12 20ths. What about this one? We've got 6 5 20ths. So to get there, I'm multiplying by 4. 5 4 is 20. Multiply by 4. 6 4 is 24. Okay, so straight away, we can see the biggest one is going to be 6/5, which we should have been able to see this really, but working it out, just make sure. And then next, we've actually got 3/5. No, we haven't. We've got 3/4, which is 15 20ths. And then finally, we've got 3/5, which is 12 20ths. So in order to solve this, I've had to turn them all into the same denominator, which is 20th. Quite long. And again, only 1 mark awarded for that. You could even have a guess by seeing that's improper, so it's probably the biggest. And then these two, usually the smaller the denominator, the bigger the fraction. So that's another way you've worked it. You can work it out. I just like to know for sure that I've got it right. Here's another type of ordering question. This time we're asked to take the fractions that are greater than 2/3. And once again, we have none of them in thirds. So they've all got different denominators, some of which are multiples of 3. In fact, they're all multiples of 3, so that should be fairly easy. So greater than 2/3. Now, 2/3, if I was to turn that into sixths, times that by 2, 2/4, so that's 4/6. So that one is greater. What about 4/9? Well, to turn 2/3 into ninths, okay, I've got 2. Times that by 3, 2 3s are 6, 6/9. So that's not greater. What about into 12ths? Well, 9 over 12 is the same as 3/4, which isn't greater than which is greater than 2/3. Sorry, yeah. And then 11/15. Okay, so 2/3 again, 15, 11 times by 5. Okay, 2 5s are 10. 10, so that one is greater because 2/3 is 10/15. And finally, 2/3. How do we get to 21? We times by 7. So 2 times 7 is 14. So 2/3 is 14/21. And that's bigger than that. So the three that were greater were 5 6, 9 12, and 11 15. Quite a lot of working out there, but we are awarded 2 marks if we get all of those correct. I would imagine that if we got 2 out of the 3, we'd get 1 mark. Okay. All right. Thank you for watching. I hope you enjoyed the video. If you want more videos on primary education, anything to do with helping with the Year 6 SATs, please check out the channel, Teachers That Tutor. Subscribe for more videos on primary education and leave a like if you enjoyed the video today. Thanks for watching, and I will see you in the next video. Thanks, guys.